Hello viewers, welcome to Bhadra Academy. Once again, we are here with another video of CUET undergraduate program, where today we are going to discuss about the types of magnetism, right? Also, you can see our phone number where you can contact us about the CUET undergraduate program courses, about the fee structure and the course structure, right? And answer your queries. So let's begin with our topic, that is types of magnetism. Okay. So if we see, this is a bar magnet we can see here, and a bar magnet exhibits magnetism, and these are the magnetic lines of force. From the north pole the magnetic lines of force are exiting, and from the south pole it is entering inside the magnet. So therefore all the magnetic materials, they contain certain magnetic moments that we can say, and therefore they behave in a similar microscopic bar magnets, small bar magnets, and therefore they are classified into different magnetism that we are going to see, right, according to the magnetic material, the molecular composition, and these are denoted by the arrows, right? These magnetic small movements are denoted by the arrows. So very first we can see that is paramagnetism. The first type of magnetism is paramagnetism, where we can see that in paramagnetism the magnetic movements inside the material, that is in a very random way, right? So therefore this random movements ultimately they result into zero magnetism, okay, or very less, you can say, magnetism. So paramagnets are basically the magnetic moments are randomly oriented, and due to thermal fluctuations there is no magnetic field, right? So it does not exhibit any magnetic field. But however, what we can do, we can apply magnetic field, and after applying magnetic field all the movements will align itself, right, on a particular direction, and then the whole material will become a magnet, and that is known as magnetization, right? That process is known as magnetization, and according to the magnetic field applied, this will be a stronger magnet. So this is known as paramagnetism, where by applying magnetic field we can make a magnet, right? Similarly, if we see, the next is ferromagnetic. In ferromagnetism you can see here all the magnetic moments are aligned in a particular direction, and now we can have this whole material as a permanent magnet. So here also we can see that all the magnetic moments in ferromagnet have the tendency to become and aligned in a parallel to each other and influence the magnetic field. However, unlike magnetic moments in a paramagnetic, the moments will then remain parallel in the magnetic field as it is not applied. So it means that if we apply a magnetic field also, then also it will be aligning in a stronger direction. After removal of the magnetic field also it will remain as such. So it means the magnetism will never end here. Then it is antiferromagnetism. Since anti is there, so it is opposite of the ferromagnetism, right? So here what is happening, that the magnetic moments, they are equally oriented into opposite directions, and finally you have the net zero magnetism, right? So therefore all the magnetic moments of magnetic ions are aligned in anti-parallel to each other. Here every magnetic moment was in parallel, but here it is anti-parallel, and therefore ultimately the net magnetism becomes zero, okay? So the next, if we see, so this is ferrimagnetism, right? So ferrimagnetism is what, where the magnetic moments are definitely aligned in anti-parallel, but here the opposite alignment is what, somewhat less in strength, right? So the magnitude is less, so net magnetism is again in upward direction, okay? In earlier we have seen that where the net magnetism was zero, but here if you see, it will have a minute magnetism in the upward direction, and that is known as the ferrimagnetism, right? So the magnetic moments are not of the same size, and therefore if you see, the overall magnetization is produced a little bit, very less positive contribution, okay? And the last one is diamagnetism. That is what, it repels the magnetic lines of force. It means that the magnetic moments are aligned in opposite of the direction of the magnetic force that is applied. So therefore it is diamagnet, where it usually gets repelled from the magnetic lines of force, okay? So these were the types of magnets that we have discussed. I hope that you have understood. We'll keep bringing such videos for you. Thank you so much.